Hello, grade 10s. We are going to start section 4.2, which is about irrational numbers. But before we do that, we're going to talk a little bit about the number system. So this diagram here is a visual for the number system, but I'm just going to tell you a little story about how it came to be. So we started way back in the days of the caveman, and the caveman could only count things that they could see in front of them. We call these natural numbers. So natural numbers are like 1, 2, 3, and so on. So only things they could count. 1 drumstick, 2 drumstick, 3 drumstick, okay? Then as people started evolving, we needed the idea of having nothing. So we included a number we call 0. So 0 and 1, 2, 3, 4, 5, and so on would be the whole numbers. So again, the whole numbers includes all of the natural numbers, but now it also adds in a 0. So people needed the idea of having nothing. Then once we got into more of the idea of having nothing, we also got into the idea of owing something. So now you took 1 drumstick from me, now I have -1. So people started evolving more into getting integers and needing an idea to represent negative. So this would be like -1, -2, -3. Note that integers also includes all the whole numbers and all the natural numbers. Once again we evolved even more, we started needing the idea of money. So once money came around, then we got into the idea of rational numbers, which would include, again, all the integers, whole numbers, and natural numbers, but now it also includes half of things, so fractions. So half of $1 or $1.50 or things like that, they can also be negative, so -2.25. Okay, something like that. So again, rational numbers, they include all the integers, they include the number 0, and they also include all the natural numbers. Then we said, well, what if a number can't be written as a fraction? What if it can't be a nice decimal number? So all these ugly numbers we call the irrational numbers. Now the irrational numbers are separate from the rational numbers. The irrational numbers are numbers like pi. Remember, pi is 3.14159, and it continues on forever. It never stops, it never ends. Also numbers like square root of 2. Square root of 2 is an ugly number. It never stops, it never ends. So these irrational numbers never stop and never end, whereas the rational numbers could all be written as a fraction. Think of even the integers, like -3/1. That can be written as a fraction. 0 could be 0/1. Natural numbers, 3, could be 3/1. So the rational numbers are all nice numbers. The irrational numbers are your ugly numbers. So let's write this down formally in our notes. So radicals that are square roots of perfect squares, cube roots of perfect cubes, and so on are rational. Again, that's because they're nice. Such as the square root of 4, that equals 2. That's a nice rational number. Rational numbers have decimal representations that either stop or repeat. So for example, 1.5, that one stops. 1.33333 repeating. That one goes on forever with a whole bunch of 3s. Irrational numbers cannot be written in the form of a fraction, where m and m are nice integers. So this basically means that a decimal of an irrational number, it never stops and it never repeats. So these are ugly numbers. Again, square root of 2, if you type that into your calculator, it goes on forever. Pi is 3.14159, and it will go on forever and ever, never stopping. So these are examples of irrational numbers. So let's look at determining if these are rational or irrational. Let's call the rational ones R, the irrational ones I. So the first one, -3/5, that one is a fraction, so that is rational. Root 14, now if I type the square root of 14 into my calculator, I end up with 3.74165737, and it does not stop and not repeat. So this is going to keep going on forever, which means it's irrational. The next one, cube root of 8/27. Let's see, the cube root of 8 is 2, because 2 times 2 times 2 is 8. And the cube root of 27 is 3, because 3 times 3 times 3 is 27. So this actually can be written as 2/3. 2/3 is a nice fraction, so that would be rational. Let's check another one out. This one is ordering irrational numbers on a number line. So some of these numbers work out nicely, some don't. What we need to do first is calculate all of them. And we can use our calculators to help with this, which is something some of us might not understand how to do. So let's look first of all at the cube root of 13. Your calculator has a button. It might say something like this, x root y, where you actually have to type in the index. So in this case, the index would be 3. Your calculator might also have a nice cube root button. However, when you get into bigger roots, you're still going to need to find that x root y button. So here, if we type in the cube root of 13, make sure you find this on your calculator. You should get 2.3513, and it's going to continue on forever. Then let's look at the square root of 18. Again, you should have a square root button on your calculator, and you'd get 4.2426. And let's continue typing these into our calculator and finding the answer. So you should double check that all of your answers look like mine. Then let's go ahead and see where these would go on a number line. So I've created a little number line at the bottom. Remember to pause the video at any time if you need to catch yourself up. The first number here, cube root of 13, would go at about 2.3. So I'm going to put it right about here, and that is the cube root of 13. Then I'm going to put the square root of 18. That's at about 4.24. That's the square root of 18. Then I've got the square root of 9. It's here at 3. Square root of 9. Then I've got the fourth root of 27. So that's going to be right ahead of the cube root of 13, so the fourth root of 27. Sorry that this is a little tough with my iPad here. And then the cube root of -5, we said, is at about -1.7, so somewhere in here, the cube root of -5. And that would be how to put them on a number line. So to finish off today's lesson, please complete page 211, number 3, 4, 9, and 15. And let me know if you need any help. Have a great day.